In the cold expanse of our solar system, Jupiter reigns supreme, a colossal giant swathed in swirling clouds. But Jupiter holds a secret, the Great Red Spot, a storm so vast it could swallow Earth whole. This crimson tempest has raged for centuries, a swirling maelstrom wider than our planet. Imagine a hurricane that never ends, its fury undiminished by time. The Great Red Spot is not just a storm, it's a window into the raw power of nature. It reminds us of the vast, awe-inspiring forces at play in our universe. For centuries, the Great Red Spot was a swirling mystery in the depths of space. Early astronomers could only marvel at its fiery hue and persistence. As technology advanced, telescopes grew more powerful, and spacecraft captured close-up images of this vortex. These leaps brought us closer to understanding the forces behind this enduring storm. The Great Red Spot is more than a scientific curiosity, it's a testament to human inquiry. By studying it, we gain insight into our own planet's weather, and the balance of forces shaping our world. Join us as we journey to Jupiter, exploring the science, history, and future of the Great Red Spot. What secrets does this storm hold for our understanding of the cosmos? Our journey begins in the 17th century when telescopes were new and the world was full of discovery. Robert Hooke, a British scientist, was among the first to document a strange spot on Jupiter in 1664. A year later, Giovanni Cassini observed the spot in more detail, tracking its movement across Jupiter's face. These early observations hinted at a massive storm system, but its true nature remained mysterious. For over a century, astronomers noted the spot's changing appearance and persistent presence. Some speculated it was a mountain or a sea, others thought it a permanent atmospheric feature. But only with more powerful telescopes and the dawn of the space age did the secrets of the Great Red Spot begin to unravel. The mystery deepened, setting the stage for future exploration. The 19th century brought better telescopes, revealing the spot as a dynamic, swirling storm. Astronomers tracked its movements, discovering its immense size and longevity. Unlike Earth's hurricanes, which last days, the red spot persisted for centuries. What could sustain such a storm? The mystery captivated scientists and the public alike. The space age brought new opportunities. In 1973, Pioneer 10 captured the first close-up images of the Great Red Spot. These images revealed its intricate structure and confirmed it as a colossal swirling vortex. The red spot's true nature was finally coming into focus. The Great Red Spot story is full of twists. In the late 19th century, astronomers noticed the spot fading. Its red hue dimmed, its size shrank. Some thought the ancient tempest was ending and headlines predicted its demise. But astronomers knew the spot had faded before, only to return stronger. This time, too, the red spot persisted, though diminished. Its resilience continues to captivate scientists. The reasons behind its fading and resurgence remain a mystery, fueling ongoing research. Jupiter, like the universe, is full of secrets yet to be unraveled. What is the Great Red Spot? Picture a hurricane wider than Earth, raging in Jupiter's atmosphere. It's a swirling mass of hydrogen and helium, a high-pressure system with winds up to 400 miles per hour. These winds create a maelstrom of clouds and gas, a storm of unimaginable scale. Unlike Earth's hurricanes, the red spot is incredibly stable, persisting for centuries. Its secret lies in Jupiter's unique atmospheric dynamics. The red spot is more than a whirlwind, it's a marvel of planetary weather. What keeps it alive for so long? Jupiter's deep, turbulent atmosphere sustains the red spot. Its distinctive crimson hue likely comes from complex molecules, churned up from below and altered by sunlight. These molecules act like paintbrushes, coloring the clouds from within. The red spot is dynamic, its shape and color shifting over time. Sometimes it's a deep red, other times pale orange or white. The storm is a living, changing masterpiece on Jupiter's canvas. The red spot's color and intensity change with the storm's strength and chemical mix. It drifts westward across Jupiter, completing a circuit every 9.9 Earth days. This colossal storm waltzes across Jupiter's face, a mesmerizing sight. The red spot shares the atmosphere with other storms, white, brown, all swirling in a complex ballet. Sometimes these storms interact, creating intricate patterns. Jupiter's atmosphere is a stage for this ever-changing dance. The red spot's longevity is a puzzle. On Earth, hurricanes fade as they lose their energy source. Jupiter, a gas giant with no solid surface, has an atmosphere fueled by internal heat and rapid rotation. This creates powerful jet streams and massive storms like the red spot. Imagine Jupiter's atmosphere as a boiling pot, with the red spot as a swirling bubble trapped by jet streams. These invisible walls confine the storm, preventing it from dissipating. The red spot endures, powered by Jupiter's vast energy. Earth's hurricanes are sprinters. The red spot is a marathon runner. It draws energy from Jupiter's internal heat and from devouring smaller storms. This storm cannibalization, observed by astronomers, helps sustain the red spot's fury. Jupiter's storms remind us how different and powerful weather can be on other worlds. At the heart of the red spot lies a mystery. Its core is a region of intense vorticity, where winds spin at their highest speeds. This vortex acts like a giant flywheel, storing energy and maintaining the storm's rotation. The scene is both terrifying and beautiful, a testament to Jupiter's atmospheric power. The red spot's existence is a delicate balance, maintained by powerful forces and intricate interactions within Jupiter's turbulent atmosphere. If jet streams weaken or the supply of smaller storms dwindles, the stability of this massive storm system could be threatened. Without these vital elements, the red spot could eventually fade away, disappearing from Jupiter's face after centuries of dominating its atmosphere. For centuries, the Great Red Spot has been a fixture on Jupiter, but recent observations show it's shrinking. Once wider than 3 Earths, it's now diminishing. Scientists compare it to a balloon slowly deflating, but the process is far more complex. Decades of observations revealed subtle changes in its size and shape. The red spot's future remains uncertain, but its legacy endures. Measuring a storm on another planet millions of miles away is no easy feat. It's not like we can simply stick a ruler up to the Great Red Spot and call it a day. Instead, astronomers have developed ingenious methods to track the storm's size and shape over time. These methods, like cosmic yardsticks, allow us to measure the red spot's dimensions with remarkable accuracy. One of the primary tools in our cosmic toolkit is the Hubble telescope. By carefully measuring the red spot's angular size, the amount of space it appears to occupy in the sky, and knowing the distance to Jupiter, astronomers can calculate the storm's actual size. These measurements, taken over decades, have revealed a clear trend of shrinkage. But telescopes are just the beginning. Spacecraft, dispatched on daring missions to Jupiter, have provided us with even more precise measurements. These spacecraft, equipped with high-resolution cameras and other sophisticated instruments, have captured detailed images of the red spot, allowing scientists to track its size and shape with unprecedented accuracy. The evidence is clear. Jupiter's Great Red Spot, this colossal and ancient tempest that has raged for centuries, is slowly but surely shrinking before our eyes. Once large enough to swallow 3 Earths, it now appears to be steadily diminishing in both size and intensity, a shadow of its former self. But the question remains, why is this happening? What is causing this legendary storm, which has persisted for generations, to finally lose its strength? What powerful forces are at work, driving the gradual demise of the red spot? Is it a natural cycle, or is something fundamentally changing within Jupiter's atmosphere? Scientists believe that the answer likely lies in the complex and ever-changing dynamics of Jupiter's atmosphere, a world of swirling clouds, powerful winds, and turbulent storms unlike anything on Earth. One possibility is that the jet streams, those powerful high-speed rivers of wind that encircle the planet and confine the red spot, are weakening or shifting their positions. These jet streams act as barriers, preventing the storm from dissipating into the surrounding atmosphere. These jet streams, driven by Jupiter's immense internal heat and rapid rotation, are like invisible fences that corral the red spot, keeping its energy contained and its structure intact. Without them, the storm would quickly unravel. If these fences weaken or shift, the red spot could lose its confinement, allowing its energy to spill out into the vastness of Jupiter's atmosphere. This would cause the storm to gradually shrink, its once mighty winds dispersing and fading away. Another possibility is that the red spot is simply running out of fuel, losing the very source of energy that has sustained it for so long. As we've seen, the red spot maintains its energy by absorbing smaller storms and eddies that it encounters in its path, feeding off their power to keep itself alive. But what if the supply of these smaller storms is dwindling? If fewer storms are available to be consumed, the red spot may be slowly starving, unable to replenish its energy reserves. Like a fire without logs, the red spot could gradually fade away. its energy depleted, its rotation slowing, and its once vivid colors fading into the clouds of Jupiter, until it eventually disappears altogether, leaving behind only a memory of its former glory. The fate of the Great Red Spot remains uncertain. Will this ancient storm continue to shrink, eventually fading into a mere shadow of its former self? Or will it rebound, its energy replenished by some unseen atmospheric process? Only time will tell. But one thing is certain, the Great Red Spot, even in its twilight years, continues to captivate and inspire us. It's a reminder of the vastness and wonder of our universe, of the powerful forces at play in the cosmos, and of the enduring human spirit of exploration that drives us to unravel the mysteries of the universe around us. The Great Red Spot's shrinking has sparked a flurry of speculation and debate among scientists. For centuries, this colossal storm has been one of the most recognizable features in our solar system, a swirling crimson eye that has captivated astronomers and inspired countless observations. But now, as it steadily contracts, the question on everyone's mind is, what does the future hold for this legendary tempest? Will this iconic storm eventually vanish from Jupiter's face entirely, leaving behind only memories and historical records? Or could it transform into something new, perhaps a series of smaller storms or a faint ghostly remnant barely visible to our telescopes? Or will it stabilize at a smaller size, a persistent reminder of its former glory? Some researchers suggest that the storm could reach a new equilibrium, maintaining a reduced but still significant presence for generations to come. The answer, like the swirling depths of Jupiter's atmosphere itself, remains shrouded in mystery. Jupiter's weather is a complex and dynamic system, with forces at play that we are only beginning to understand. Some scientists believe that the red spot's shrinkage is a sign of its impending demise. They worry that the processes fueling the storm are weakening and that its days may be numbered. They point to the ongoing changes in Jupiter's jet streams, those powerful winds that confine the storm, as evidence that the delicate balance that has sustained the red spot for centuries is unraveling. These jet streams act as invisible walls, trapping the storm's energy and keeping it spinning. Like a weakening dam no longer able to hold back a raging river, these shifting jet streams could eventually allow the red spot's energy to dissipate into the surrounding atmosphere, causing it to gradually fade away. The storm's once mighty winds could slow and its vibrant colors could dull, until it is lost among Jupiter's ever-changing clouds. Imagine a world where Jupiter, that familiar gas giant with its swirling bands of color, no longer bears the mark of its most famous feature. The planet would look strangely empty, its personality forever changed. For centuries, the Great Red Spot has been a symbol of Jupiter's power and mystery, appearing in the earliest telescopic drawings and inspiring generations of skywatchers. It's a thought that both intrigues and saddens astronomers, who have long used the red spot as a marker to track Jupiter's atmospheric dynamics and as a source of endless fascination. Its disappearance would mark the end of an era but also open new chapters in our understanding of planetary weather and the ever-changing nature of our solar system. However, not all scientists are convinced that the red spot is headed for oblivion. They argue that the storm has experienced periods of shrinking and expansion in the past, a natural ebb and flow driven by the complex interplay of atmospheric forces on Jupiter. Just as Earth's weather patterns fluctuate with periods of intense storms followed by calmer spells, so too might Jupiter's atmosphere undergo cycles of heightened and reduced activity. These scientists point to historical records of the red spot dating back centuries that suggest the storm's size has fluctuated over time. While the current trend of shrinkage is undeniable, they argue that it's too early to say whether this represents a terminal decline or simply a temporary dip in the red spot's long and storied history. Imagine the red spot as a cosmic yo-yo, its size expanding and contracting over time, responding to the unseen forces at play within Jupiter's atmosphere. It's a testament to the dynamic nature of our universe, where even the most seemingly permanent features are subject to change and evolution. The Great Red Spot, whether destined to fade away or to re-energize and grace Jupiter's atmosphere for centuries to come, remains a source of endless fascination and scientific inquiry. Its swirling crimson vortex has become an icon not just of Jupiter, but of planetary science itself, a living symbol of the mysteries that still linger in our solar system. For generations, astronomers have gazed at this massive storm, wondering about its origins, its persistence, and what secrets it might still hold beneath its turbulent clouds. It serves as a reminder of the vastness and mystery of our universe, a swirling vortex of questions yet to be answered. The red spot's sheer scale and power dwarf anything found on Earth, making it a humbling sight for anyone who contemplates the forces at play in our solar system. Its presence invites us to look beyond our own world and consider the incredible diversity of phenomena that exist among the planets. This storm, a colossal tempest that has raged for centuries, has captivated astronomers and casual stargazers alike, fueling our imagination and challenging our understanding of the cosmos. Its ever-changing shape and color have inspired countless observations, sketches and photographs, each one adding a new layer to our collective curiosity. The red spot is not just a storm, it is a living laboratory, a place where the laws of physics play out on a grand scale. The red spot story is a testament to the power of observation, the ingenuity of scientists, and the humbling realization that we are still uncovering the secrets of our cosmic neighborhood. Each new mission to Jupiter, each new set of data, brings with it the potential for discovery and surprise. The dedication of researchers around the world has transformed the red spot from a distant curiosity into a dynamic subject of ongoing exploration. Each image captured, each measurement taken, each theory proposed, brings us closer to comprehending the forces that shape not only Jupiter, but also the countless other worlds scattered throughout the universe. The red spot acts as a bridge between our desire to understand the familiar and our urge to explore the unknown, reminding us that every answer leads to new questions. As we continue to explore the cosmos, the Great Red Spot stands as a beacon, a reminder to embrace the unknown, to question our assumptions, and to never stop marveling at the wonders that lie beyond our own pale blue dot. It encourages us to keep pushing the boundaries of exploration, to send new missions, and to dream of what we might one day discover. And who knows what future discoveries await. Perhaps the next generation of explorers will witness changes in the red spot that we can only imagine today, or uncover clues that finally explain its mysterious origins and fate. Perhaps one day we'll unlock the secrets of the red spot's longevity, its fiery hue, and its ultimate fate. The answers may reshape our understanding of planetary weather, or even offer insights into the atmospheres of distant exoplanets orbiting other stars. Until then, it remains a symbol of the enduring allure of the cosmos, a swirling testament to the boundless wonders that continue to inspire and challenge us. The Great Red Spot endures as a vivid reminder that the universe is full of marvels waiting to be explored, and that our journey of discovery has only just begun.